Ooh, no, inscribed is inside, so circumscribed is outside. Now, I apologize, I'm going to cheat. We've got an octagon outside a circle. So I'm going to draw the octagon using my fancy math software, and then I'm going to draw the circle. Wouldn't it be nice if you had this tomorrow on your quiz that you could just do this? That would be really nice. Okay, anyways, so you drew that, and I did this so I could speed up the process. Now, the radius of the circle is 4. Let me show you what radius will do you no good to draw. This is the one you would not draw.
That's the apple.
Oh, wait.
We'll draw that one.
Sure, draw that one. Go for it. That one.
Because it's not connected.
4. Yep. You need to touch the circle and the octagon at the same time. You need to touch both of them. If you're not touching both of them, then throw your hands up and walk away. So, I'm going to draw this one right here. I'm touching the circle and the octagon. That's 4. In the octagon, because we're done with the circle now, in the octagon, is that the apothem or the radius? That's the apothem. So the radius of the circle ended up being the apothem of the octagon. Not a big deal, but it is important that you know that the radius is not always the radius. So I'm going to make myself a right triangle, because we don't have a side. To find the area, you need an apothem and you need the sides. We don't have a side yet. Do we need the radius? Do we need this length?
Yes.
Is there an R in the formula for the area of a polygon?
Yeah.
You say that with such conviction. No, there's no R there. We don't need a radius. We are looking for the side only. The side will get us the perimeter. Okay, so then we talked about yesterday, there's 2 ways to find the missing angle. An octagon is not one of our special cases, so we have to find the missing angle. You were to choose which one you liked better, but I voiced that I like this one better. 360 divided by 16. Where did I get 16?
8 times
8 times 2. The number of triangles I would draw if I drew triangles all around it. So 360 divided by 16, 22.5. Sine, cosine, or tan?
Cosine. Sine, cosine, tan.
Tangent. Tan. So, tan of 22.5, are you writing this down? Equals opposite over adjacent.
multiply.
Very good.
What?
4 times tan 22.5. This is when you put your pencil down and you pick your calculator up. Everyone pick their calculator up. Yay, Frankie. Make sure you're in degree mode. Okay, is your calculator in your hand?
Yes.
Okay. First thing that we're going to do is 4 times tan 22.5. What did we just find? Half of a side. What do you want to do? Double it. Times 2.
30.31.
What's that? That's a side. How many sides are there?
8.
Times 8. Whatever number's in your calculator right now, that's the perimeter. What do you want to do next?
Multiply by the apothem.
Multiply it by 4. That's the apothem. And last step, divide by 2. And you should be staring at 53.019. 53.02. It didn't tell you what to round to, so you could have rounded to whatever you want.
Whatever we want, like we could go all the way down.
For the apothem, is that halfway for like not triangles?
This is an even numbered shape. So when I draw from the center to a side, if I go this way, I'm going from a center to a side. Yes.
Okay.
Do you ever need to know the height of an octagon, though? No. Okay. Good question. Moving on. The next one was 12. Number 12. The apothem of a regular pentagon is 13. Find the area of the pentagon. So no inscribed or circumscribed for this one. That's nice. Draw yourself a pentagon. How many sides is that?
5.
I bet you'll see one like this tomorrow. We've got 13 from the center to a side. That's what an apothem is. It's from a center to a side. That's 13. That's all we've got. That's all they gave us. Was that the pentagon's regular and that the apothem's 13. You always make yourself a nice right triangle. And now you find the angle.
360.
360 divided by 10. That's nice.
36.
36-degree angle. Give you a hint, you're going to use 10 every single time. Well, unless I give you a radius instead of an apothem. But when I give you an apothem, you're definitely going to use tan. Tan 36 equals opposite over adjacent.
Multiply.
So we are in the same exact boat as last time. Let's do it. Pin down, calculator up.
Why 30?
Oh, I don't know, 13, sorry. Thank you. Frankie's paying attention. Okay, I think it's because I wrote my 1 so far away from my 3. I don't know. Ready? 13, 10, 36. What do we do next? Times 2.
Times 2.
Now we've got a side. Now what? How many sides are there?
5.
Times 5. Awesome. That's the P. That's the perimeter. Now what?
Multiply by 5.
Times apothem 13. Excuse me. And divide by 2. Beautiful. 613.93, or like I said, whatever you round to, because on the worksheet it didn't tell you what to round to. On the quiz it definitely will. Okay? Last problem. Everyone look at 13 with me. We haven't done a hexagon yet, so let's do a hexagon. A regular hexagon and a square are circumscribed about a circle with a radius of 10. So are the shapes outside or inside the circle?
Outside.
They're outside. I would recommend to draw them separately. I think if you drew all of those in the same picture, you might get a little confused. So we've got a hexagon, outside, a circle. Yay. Ooh, that's nice. Okay, almost. The circle has a radius of 10. The circle has a radius of 10. Remember, when the shape's outside, the radius of the circle is going to be the apothem of the shape. Yeah, when the shape is outside. All right, let's do a square next. We need a square outside a circle. Ooh, cool. And the circle has a radius of 10. The square is going to be way easier. Let's do that one first.
Okay.
How long is one side of that square? 20. Very good. What's the area of that square? Through your head. 400. We now are halfway-ish done. There's the area of the square. Now let's find the area of the hexagon. A hexagon is one of our 3 special cases. That's the word I use, cases. So it's 30, 60, 90. So we're not using trig. We're not doing the 360 divided by blah, blah, blah. So there's our right triangle. Here's our 60, because 120 divided by 2 is 60. There's our 30. Oh man. 10 is across from 60. Are y'all sad? Sad. 10 over root 3. 10 root 3 over 3. I'm getting some blank looks.
He's being rude.
Okay. Your towel's young.
I said I'm evil. You are evil.
10 root 3 over 3. Mental note. When Miss Hannon makes seating chart next 6 weeks, don't put Coon by Carter. Got it. Okay.
No, I'm just kidding.
See, you love it.
How long is one of the sides? Do y'all know what 10 root 3 over 3 plus 10 root 3 over 3 is?
20
It's 20 root 3 over 3, okay? It's kind of scary, but we got it. So, apothem, which is 10, times perimeter. What's 20 times 6? 120. Root 3 over 3.
So that's 40, right?
Yep. Isn't that nice? 120 is divisible by 3. Let's go ahead and do that. I like that better. 10 times 40 divided by 2. Do you type square root 3 into your calculator? No. 10 times 40 divided by 2, which is just like saying 5 times 40. 200.
Root 3.
Root
How'd you
3.
get 40 again?
Okay.
Wait, is that the area of the circle or hexagon?
We never find the area of a circle. We haven't even learned that yet. So it's the area of the hexagon.
Oh, yeah.
This is the answer. 200 root 3 minus 400.
That's our answer.
That is the answer. Oh, sorry, it's the opposite. Sorry.
Yeah.
Sorry. 400's more than 200 root 3. What were you asking where the 40 came from?
Yeah.
So we got 120 root 3 over 3. And 120 divided by 3 is 40. 3 goes into 12 4 times.
How'd you get 120?
Oh, okay, so one side is 20 root 3 over 3. There's 6 sides, so 6 times 2 is 12. Okay. Now, if we wanted a decimal answer, we could put this in our calculator. 400 minus 200 root 3, and that's about 53.58. Okay? All right, we are done working homework problems. Title your notes, circles.